Today's lesson is on evaluating and graphing a piecewise function. A piecewise function is a function that is defined by two or more equations over a specified domain. For example, we're given the function f of x is equal to 3x plus 5 if x is less than 0, and f of x equals 4x plus 7 if x is greater than or equal to 0. When evaluating a piecewise function, you have to decide which part of the function you're going to use. In our first example, we want to evaluate f equals f of negative 2. To evaluate f of negative 2, we have to decide, are we going to use the first part of the function or the second part of the function? Since negative 2 is less than 0, we're going to use this first part of the function, 3x plus 5. So I'm going to substitute negative 2 in for x. I get negative 6 plus 5, or negative 1. So f of negative 2 is equal to negative 1. To evaluate b, f of 0, since 0 is greater than or equal to 0, we're going to use the second part of the function. So therefore, f of 0 is equal to 4 times 0 plus 7. 4 times 0 is 0, plus 7 equals 7. Therefore, f of 0 is equal to 7. You never substitute the number in for both parts of the equation. Just one or the other, depending on the value. Next, we're going to talk about how to graph a piecewise function. So suppose we're given that f of x is equal to x plus 3 if x is less than negative 2, and f of x is equal to x minus 3 if x is greater than or equal to negative 2. To graph this, we want to make a table of values for each part of a graph. So I'm going to start with this top part. Make a table of values. And I'm going to substitute numbers in for my function. I'm going to start at negative 2 and then pick two more values that are less than negative 2, since this is true anytime x is less than negative 2. So negative 3 and negative 4. I start by substituting negative 2 into my function. Negative 2 plus 3 is 1. Substitute negative 3 in. Negative 3 plus 3 is 0. Substitute negative 4 in. Negative 4 plus 3 is equal to negative 1. And then I can plot those points in my graph. Now notice that x has to be less than negative 2, not actually equal to negative 2. Therefore, this point on my graph is going to be an open circle. So at the point negative 2, 1, I'm going to have an open circle because the function is not defined at that particular value. Then at the point negative 3, 0, when x is negative 3, f of x is 0. Right there. And then finally negative 4, negative 1. And then I'm going to connect those points with a line. Now I need to graph the second half of the function. F of x equals x minus 3 when x is greater than or equal to negative 2. Again, I'm going to make a table of values. And I'm going to start with negative 2, but this time pick values that are greater than negative 2, like negative 1 and 0. If I substitute negative 2 into this equation, negative 2 minus 3, I get negative 5. Substitute negative 1 in, negative 1 minus 3, I get negative 4. Substitute 0 in, 0 minus 3, I get negative 3. Now I plot those points. In this case, x is greater than or equal to negative 2. Since it's or equal to negative 2, I'm going to have a closed circle at negative 2, comma, negative 5, my first point. And I'm going to plot a point at negative 1, negative 4, and finally 0, negative 3. And I'm going to sketch my line. And that's the graph of the piecewise function. Part B of the graph asks us to determine the function's range. If you recall the range, are all the possible y values. Since this graph continues forever in the negative direction and in the positive direction, our range is going to be negative infinity to infinity.